to start off with some Twitter Bootstrap stuff, which got delayed from previous lessons. So we wanted to hit the grid system, which is really important. We're going to use that for all of the layouts in our applications, and so that's worth going over. So we're going to start with that. We're going to then return to the control flow stuff in the JavaScript introduction that we didn't get to last time. And that won't take too long, I don't think. And then we're going to go on to functions, which is the material that we had originally planned for today. So we've got 3 things to do today. And I think we'll be in good shape to cover it all. So announcements. So we're going to hang out at McNally's tonight. So feel free to come by afterwards. And then what was the other one that I mentioned? Excuse me, on Friday is the entrepreneurial get-together for Launch Oklahoma at the 404. So that's going on. Any other announcements? Anybody know anything else that's going on related to startup scene in Oklahoma right now, or Oklahoma City? Ignite is tomorrow. That's right. So Ignite OKC is tomorrow. I'm actually speaking at Ignite, so giving a little 5-minute presentation. But I think you have to RSVP for the event or register for the event. It's igniteokc.com. Yes, igniteokc.com. And maybe even they have tickets. I'm not sure. I had not been to one previously. So, yes.
You have to buy a ticket.
Looks like you have to buy a ticket. So. But that's happening tomorrow. It'll be cool. It'll be these 5-minute presentations with automatic moving slide decks, and people will be hanging out, having drinks, and chatting, and sort of networking and stuff. So, anything else? Probably other stuff happening, right?
Office hours tomorrow, right?
Office hours tomorrow. Yes, thank you. So I will be in the city at Camps 1910 from 11:30 to 1:30, and then I'm going to make it down to Norman for our meeting, Renee, at 2 o'clock. But it's open office hours, so come and talk about anything that you want to talk about. I'll just be hanging out. And don't worry if nobody comes. I'm just going to do work, so it works either way, right?
Relationship problems too.
Relationship problems as well. I have a little sign that I hang on the door that says the psychologist is in. I think that's what she said. Or the doctor is in. 5 cents, yeah. So, yep. So office hours tomorrow. Cool. Okay, so let's hit up this grid system. So everyone get bootstrap.com page. And we might also go to the work that we were doing in class that involved all the Twitter Bootstrap stuff. So you'll have to find where you saved that. I put it in one of my directories here. Let's blow this stuff up so everybody can see what's going on. All we're going to do is find this directory that we put our node project in and get it started again. And so I put mine in this Bootstrap and called it intro Bootstrap, maybe? Yeah, that looks right. And so I want to open up that folder in Sublime, as we've been doing, so that I have access to all of those files. So eventually you should get what looks like this. And if you remember, we probably have some stuff in our public text page. We'd worked on that forms page last time. And this is the one where we moved all those Bootstrap files into the JavaScript folder and the style sheets folder and so on. When you find that, let's go ahead and create another file. So you can either use touch, and we'll call it grid.html, or you can just create it in Sublime and immediately save it, whatever you want to do. We just need another HTML file inside of that public directory. I probably put it in the wrong place. Yes, I did. So make sure you put it inside the public directory. And Sublime should reflect the fact that that's going on, right? You should have a grid.html inside this public folder. And with that, we can just start up our Node application, because Node will see any changes that we make to the HTML automatically. So, and recall how we do that from the main root folder of our application. We do npm start, right? So make sure you're in that main root folder of the application and do npm start. You should see something like that. And we can confirm that that is working by going to our web browser, using localhost 3, and it should launch up that index.html one that we were working on. So however far you got with that in class. And we've got MyWo available if anybody is running into trouble. I don't think Shelby is here this afternoon. Cool. So we should also see that we've got a I have an incoming video call, which shouldn't be the case, right? We should also see that we have this grid.html file. So if we do /grid.html, we get a blank page. We shouldn't get an error, but we should get a blank page. That means that it's located in the public directory correctly and is serving up that empty page for us. Okay, so we're creating a new Bootstrap page. Where do we start every time we want to create a new Bootstrap page? Yes, Bootstrap. So we want to use the template that Bootstrap provides. And that is in the Getting Started section. So I clicked on that link here, and then it's over on Basic Template. And again, what do? We just copy paste this, literally. That is the right thing to do, so there's nothing wrong with that. And in Sublime, paste grid.html. What are they?
The JavaScript file and the CSS.
That's right. And so why do we have to fix them? So it knows where to look. Why? Because in our public directory, we have a style sheets and a JavaScript folder. We do not have a CSS and a JS folder, right? So I changed the CSS in this link href at the very top to style sheets. I should turn off my phone. And at the very bottom, script needs to become JavaScripts. But everything else remains the same. Make sure you get plural on both of those. And now, if we save that and refresh our page here, we should see a bootstrapified hello world. So the font will be sans serif, and it will be pushed all the way up against the middle there, or against the left. So what I am following for this is all available on Bootstrap's page. So again, on this back on the Bootstrap site, if we go over to CSS here, so on the top, go to the CSS in the nav bar, and the grid system is the second item here. And clicking on that, this is what we're working off of. So we're sort of going to consolidate this and talk about what's going on here. So the grid solves a particular problem. So designers commonly need to lay out web content in grids. So for the larger structure, they'll divide the page into equal-sized sections, and then allocate some portion of those sections to parts of the page. So what we're talking about, it's literally like a grid. So imagine you're looking down on a city or on county road somewhere, and you've got a web page, and they are taking this page and invisibly sort of just dividing it into equal-sized columns. And then they allow you to create rows and add content of some column size to these rows. And so a designer will commonly need to do exactly what we're seeing here on Bootstrap. So they'll want to create a sidebar, and then they'll want to have a main content area. So they'll say, hey, give me 3 of these rows over here. I'm going to make that my sidebar. And then give me the rest of this, our columns over here. And then give me the rest of these columns, and I'm going to make that my main content area. And then for more detail-oriented work, like zooming down into actual content, they're going to want their form fields to all be the same size, for example, or paragraphs, same width that is, or we want an easy way to make our page look consistent, basically. And so you'll have like a paragraph that is 3 columns long, and then a form field that is also 3 columns long, and then a button that is 3 columns long, and so on. And rather than manually specify all of that in our CSS, we can employ the grid system to do that for us. Many other CSS also provide grid systems, so it's a very common need in web page design. We can see this by looking at some sites. So like if we go to the New York Times, the New York Times employs a grid system. So this right here is a grid system, right? These are columns, there's some rows in here. We really see it if we scroll down to the page and look at like this. This right here is like classic grid system, right? We obviously have a row, and then we have some kind of columns of some kind of width, and they occupy, each cell kind of occupies a space, or its right space on the page, and everything gets the same size, yeah? You can see subgrids in here. So all of these pictures occupy the same amount of width, yeah? And then all of these leads occupy the same amount of width, and so on. So NPR does a really good job with its grid system as well. So just looking at npr.org. So here it is. So we have a sidebar over here, and then we have this main content area, but then you'll notice they'll sometimes split up the main content area in interesting ways. So here, the picture occupies the whole amount of this content area, but then here, the picture only occupies a portion of it. And then down here, you see this is like super classic grid. Row, and then 3 columns. And each row uses that same column structure.
If you go to theverge.com,
they do
yeah,
they'll do that as well.
Go to theverge.com.
Just The Verge, like that?
Yeah.
Okay.
and then scroll down. So scroll down, they'll see this.
Yeah, so also, like, that's definitely grid, right? And it's cool because you can get some neat layouts. So you can imagine that this is a row right here, and then inside rows you can add columns and then split those columns further up into further rows, and then lay out some columns in there and then split those up into further rows. So you can make really complex layouts just by nesting rows and columns. Yeah, like classic. Theirs looks like it's more column-oriented than row-oriented, but exact same idea, right? So websites use this all the time, and we needed a sort of reusable way of doing this rather than having to write it ourselves every single time. So every grid must reside in a container class. So we need a div whose class is container, and that will contain our grid. That is, according to Bootstrap's instructions, it's just necessary. So let's go ahead and do that. I'm going to put it under our header, or under our H1 right now. It's just a div class equals container. This is a great way to start just about every web page that you create. You almost always want a container div, especially with Bootstrap. Now, inside this container, we will add rows. So Bootstrap's grids always starts with a row. That is the primary unit of their grid system, or at least at the top level unit of their grid system. That means like a complete horizontal space across the page. And it's as simple as saying div class equals row. So inside the container, I add another div, and I give it class equals row, and then I close it. We can have as many rows as we want in our grid system. Yeah, so let's go ahead and add another row underneath this. And feel free to use spacing liberally so that you can the page, because it will get complex once you start to use this grid system. Okay, now we cannot add content to rows. You can't just have a row. You must have columns inside the rows in order for your content to appear correctly. This is just how Twitter's grid system works. And so we're going to need to add some additional classes here. Some kind of call class or something, some kind of column class. What do we use? So Twitter provides a number of different column layouts for their grid systems. We're going to stick with the medium column layout and see why. It has a nice effect. But something that you have to do, and this is what you've got to remember about using Twitter's grid system. In any row, you may have as many columns as you want, so as many divs whose class is some kind of column, but their lengths must add up to 12. So you can imagine that the row is split up into 12 equal-sized parts, and when you start to lay out columns, you can choose how many of those parts you want to use, as long as the total inside a row adds up to 12. And so what I mean is the call classes look like this: call-md- and some number. And so I can just do the number 12, so call md12, call-md-12, and then that is a single column in this row. And it will occupy the entire horizontal space of that row. If I wanted to make it a different size, let's say I wanted to make it size 4. Now it's going to occupy 4/12 of the page, so 1/3 of it. But I need to add another column here. I am now only occupying this much of this row. I need something to fill in the rest of that row. And so necessarily, by Twitter's specifications, I need another div that will be a column, and its class must be call md8, so that it adds up to 12, right? And so now here I've got a row and 2 columns in it. One of these columns is width 4, and one of these columns is width 8. That's all it's doing. We can't see anything on the page yet. It doesn't give us content. It just gives us sort of layout. It just gives us structure. We could have other columns. We could add more columns here. We can have as many columns as we want, as long as that 4 and the 8 or whatever add up to 12. So we could do 3, 6, 3. We could do 6, 1, 5. Whatever. It doesn't matter. You get to choose what you want the layout on your page to look like, as long as we add up to 12. So let's give it some content so we can see what this looks like. Let's just give it some lorem ipsum. So inside that column D4, I'm going to do a paragraph. And inside that paragraph, I'm going to do a lorem ipsum, even about that. And again, I'm just typing lorem and then tabbing, but unfortunately, I kind of have to do it twice sometimes. And then inside this other column here, I'm going to do the same thing. So I'm going to give it a paragraph. And in that paragraph, I'm going to give it some lorem. There we go. And save it, yeah? And so we start to lose the entire sort of structure of the page now. But I think that's pretty simple. We should be following along. So save that and look in the web browser. And this is, now we see what is going on here. Yeah? Imagine 12 pieces in this page, and I get to say this is a row. A row occupies the entire horizontal space. If you make another row, anything you put in that row will come below this row. But then I can choose how much I want each cell in this grid to occupy. This is almost like saying call span equals in a table, right? 4, and then 8. Let's do the opposite on the row below us. So we made another row. This one's an empty row. Let's do div. Let's add a column. So div class equals call dash md dash, and let's go ahead and split this one into half. So we'll do a 2 column d6s. And then again, just add a paragraph of lorem ipsum to each of those. And when you get that done, save the page and look at it. And you'll see how now it's splitting this next row into 2 columns of equal length. And so this is what's super nice about the grid system, yeah? We can have our rows be laid out differently. They don't have to be laid out in the exact same way. And we can just keep on adding stuff to this. Now, our hello world is off, so let's go ahead and put our hello world inside of a grid, inside of the grid as well. So I'm going to give it its own row. I'm going to cut it out of where it is now. And inside the container, add another row. Div class equals row. And then I'll just give it a column whose span is 12. So class equals call md12. And paste my header into there now, right? So I got 3 rows. And it lines up my hello world. Make sense? I don't think that's too bad, right? Basically, rows, column, or container first, rows, as many as you want, columns inside the rows. Make sure your column links add up to 12. What the grid system does for us that's pretty nice is automatically rearrange the contents of the page as the window size changes. And so if you're already looking this on a small screen, you'll have noticed this effect. Let's shrink this window. So I'm just going to grab it and start shrinking it. And watch what happens. We already know that the container is going to get resized. But once I reach a certain point, these columns collapse into rows automatically. This is the responsive layout that's going on. And so if you're seeing this, no is not large enough, it will look like this on a mobile device because there's not enough room to lay out lots of columns on a mobile device. So it automatically collapses them into rows. Which is pretty neat. And it goes from left to right, although you can reorder that. So, I think where it maybe starts to get a little complex, but it's still not too bad. And let me draw this on the board so that we can really see this layout. The one that I've got up here. So we got page, 3 rows. 1 row occupies the entire amount of space. The other row has been split by 4 and 8, 12. And then the other row is split right down the middle, right? All right. Now, inside any one of these columns, I can nest additional rows, okay? And then split that column up any way I want in 2 rows. So let's take this one that's 8. So it'll be, we can't see it on here, but we know where it is, right? And I'm going to split it into 2 rows. And then, again, I can add columns to those rows. Yeah? So basically, I'm re-nesting the structure. This is a recursive approach.
On 12 again, or on 8?
It has to equal 12, right? And so that's the trick, yeah? Yep, so rather than making it equal 8, we still have to have those new column lengths add up to 12. And so let's see what that looks like. I've got this, here's my column 8 right here. We're talking about this guy right here, right? So let's kill that paragraph. And immediately inside that column, add a new div whose class is row. And then inside that row, in order for any content to show up, we have to add columns. So let's add 2 columns. And let's make one of them let's just do 6 and 6 so that we keep it not too crazy. So I've added 2 columns whose, again, lengths add up to 12 for the row that is inside the MD8. And it may not be necessary, but really the right way to do this is always to have your columns appear immediately inside your rows. So it's like there's no intervening content between the column and the row, right? There's nothing in here. And then if you're going to nest rows, probably always have your row immediately appear after the column. That'll keep your HTML clean. So some of that may be necessary, some of it may not, but it's probably almost certainly good practice. And let's add a paragraph here. And for effect, let's give that paragraph a background color. So it's going to be lorem, but it's going to be some background, and I forget what they are. So I'm going to look over on my helper classes. I can add background primary. Let's do background info and background success. Okay, so P class equals bg / success. Give it some lorem. Why is Sublime so painful about giving stuff lorem? And that's going in this first column, and then in the second column, give it another paragraph, but change its background to info, just so that we can see some colors in here. And so what I've done is I've added only a single row, so I've basically taken this guy and given it 1 row, and split that row up right here into 2 columns of equal length. So now it's like 4 and 8 on the outside, so that 8 is correct. 8 still describes the whole thing. And now these 2 guys are 6 and 6. Save that and refresh the page, and you'll see the effect. Right? Now that one might seem a little silly. We're really this whole page into 3 equal-sized parts. What's the point of doing that? Well, we have this control, right? We've added a row inside of this column, so we could add another row. So let's do that. Instead of having this first row take up this entire space, let's split this into 2 rows. So I could go like that, yeah? And now I'm in control of, like, really in control of the content inside of that column. And so I've got my column D8. Here's my row. So I want to keep track of where that is. Sublime is nice enough to give me these things. At this point, it's probably a good idea to start marking these with comments. So close first nested row, or whatever you want to say. And then let's open up another row. You got to be careful here. If you get this in the wrong place, the layout will totally be hosed. So, and that's actually probably not, because that's the column. That's not where I want it. This guy. See, I already made a mistake.
Where are we trying to put it?
We want, looks like I've got div class paragraph, close that div, close. See, I'm missing, something has gone wrong here. This, you can tell where the tabbing is off, right? So let's see. That closes that guy, yes. Is that a stray div? That closes that guy. So that looks like just a stray, maybe I just had that in there. Really, we want it after this div. This is why comments are super helpful in the code. So let's put it there. All right, so now we should be able to open up a new div. Class equals row. And then in that, we could give it 2 more columns. Or let's just give it 1 column. Div class equals call md12, so we'll have it occupy the entire space. Paragraph with lorem ipsum. And so if this works, if I've got this thing done correctly, I've split this column, this cell here, into 2 rows. The first row is half and half, and the second row is the whole thing. That's what we're going for. Save it, refresh the page, and that's what we get. And so notice, importantly, we can see this working. This whole thing right here is now a row, right? And that's why we get that white space here. And then this guy is a single cell inside that row, and then we split it up into 2 rows, and we have one of these 6 and 6, and we have the other one occupy the entire space. And so now we're starting to get some really complex layout on our page. This is how the grid system works in Twitter. That's the gist of it. It's really not too bad, but you can definitely get lost in the HTML once you start nesting all of this stuff. So add comments. That's really probably the smartest thing you do before you start adding content to a column or to a row. Show that closing div. Be like, here's where I close the row. So basically this, close first nested row. Okay, here's where I close column. Here's where I close second nested row. Whatever, whatever comments are helpful to you, and that way you won't get lost in it. So, and then and then also make sure you're using tabs correctly. Anytime you're nesting a tag, tab that thing. Yeah, so you can visually see the structure of your page and the layout of your code. Cool. So, why is this awesome? We have learned, maybe without seeing its full practical effect, that HTML handles the structure of a page. It's semantics. It tells us what things in the page are, but it doesn't necessarily tell us about the layout of the page. CSS, on the other hand, is for the presentation. It's for the layout. And we've sort of harped on that and said that over and over and over, but we haven't seen the practical effect of really distinguishing the two from one another. Well, with the grid system, now we really can. Because now, for a radical change in the layout of my page, all I need to do is change the class I'm using on any one of these cells. And I can completely change what the page looks like. And I'm not changing any HTML, really. I'm only adding an attribute to my class, or changing the attribute, right? So, for example, I could change the bottom here so that it's 2 and 10. Yeah, and it will completely change what my page looks like. So let's find that last row where I've got column D6 and column D6 right there, and change the first one to column D2 and change the second one to column D10. Refresh my page, and boom, completely different layout, right? Without having to change anything else in the HTML. So this is the power of separating the two from one another. I can do something even crazier. Right? So let's make this look a little bit nicer. I think 2 is probably too small. Let's make it 4 as well, and make the second one 8. So it'll look a little bit more like that. So you can see this is our row here. Twitter gives us the ability to move columns around inside a row without actually moving them in the HTML. And so we look at this and we see how the rows or the columns are rendering from left to right. Yeah, so whichever one appears first is on the left, and whichever one appears first is. We can change that just by changing the classes. I find this a little confusing, but I want to show you that it's possible, sort of to highlight the power of CSS. Excuse me. There is a call MD push and a call MD pull class that we can add to these things. So I can say call MD push, and then I want to give it the length of which one I'm pushing, so 8. So I've added a second class to this guy. You don't have to worry about following along with this. I'm actually going to undo it after I've done it, but I just want to point this out. And then on the bottom one, I do call MD pull of the column that I want to like pull it for. I don't quite understand the significance of that. But now watch, without changing the order of the HTML, I've changed the layout of the page just by adding a class to my HTML. And really importantly, I've changed it in a way so that the structure is not linear anymore. It's not doing what you think it should do from the HTML. So that is the significance of HTML, is the semantics of the page. It's not its structure in the sense of its structure in the sense of its organization. It's the organization of the information contained in the page, and CSS controls all this stuff, all the layout. I think that's pretty incredible. I'm going to undo that. If you need to make a change like that in your page, I would move the HTML around, honestly. Because at some point you'll start looking through this stuff and be like, I have no idea why my page is laying out the way it's laying out. Lay it out in a way that makes sense just by looking at it. Looking at the code, that is. And so I move these around. I cut and paste one after the other so that I get that layout. Yeah. Does that make sense? Okay, so I want to talk about a couple of common page layouts just to give you a sense of typical ways that people are doing this. And most of our sites, so when we actually start getting into the programming of the Express web application, so we've done HTML, CSS, we're segueing into JavaScript like an introduction, then we're going to go back into actually building an Express application again. We're going to start with this. Every application that we begin, or anytime we start a project or assignment, we're going to give it a grid layout. And there's a couple of standard ones that we really like to use. There's the sidebar layout that I've been discussing that Twitter is using on its own page, where you get a column of length like maybe 4 on the left, and then the rest of the content here, and that's called the sidebar. Or you get a column of length 4 on the other side, and the rest of the content here. Very common layouts: left sidebar, right sidebar. And then another common layout is to split it into 2 sidebars. So you might do 3, 3, and then 6 in the middle, right? So 2 very common layouts. And I just want to show you how to set that up using the grid system in Twitter. That's very practical. And like I said, we'll be using it in all of our work. So let's nuke all this stuff. Keep the first row that has hello world in it, and delete everything else. So be careful where you go down to. We want to keep the container, which should be there. Yep. So you should see it from the structure that we end up with. And maybe that's a good time to add a comment. And if you forgot, I mean, just as a reminder, that weird tag with the exclamation mark, the pound is the comment, not the pound, the bang. Short for that is bang. Okay, so let's add another row. So div class equals row. And inside that row, let's give it 2 columns. Div class equals call MD. We'll do a left sidebar, so call MD 4. So we'll make the first one the smaller one, and the second one the larger one. Call MD 8. The MD there stands for medium. And then in the first one, I'll give it an H3 that says left sidebar. And in the second one, I'll give it an H3 that says main content. Close it. So really simple. This is our everything in our body now, right? Super, super, super common way to start a page. And if I save and refresh that, this is what we'll see. And we don't have any content to show it off, but we've got a left sidebar that's right here, or however big that row is, and then content over here. And as an example of what you might see with this kind of layout, I'm going to grab from Twitter's Bootstrap's components, which we didn't quite go over, but they have this component. They've got this list group component. Looks like this. I think that looks pretty awesome, so I'm going to copy paste that to give you a sense of how this might look in our page. So on the left sidebar area, I'm going to add this list group. Literally, again, just copying and pasting some Twitter Bootstrap HTML, and refresh my page. So it's like, oh, now we've got a sidebar. Yeah. And you can imagine that we've gone to our page. We could have a navigation bar up here at the top, but I also want to have some other stuff for them to be able to navigate on the subpage. Yeah. So we would use something like this, and we can use JavaScript to intercept every time they click one of these elements, and then show them different content depending on which one they've clicked. Yeah? So we'll learn how to do that later in the course. And then let me add a few more here so we can make it grow, just for example, because I think it looks really nice. There we go. And then in the main content, I'll go find another CSS thing that Twitter uses, maybe a big old panel. Yeah, we'll do a couple of panels here. I'll put that in my main content area. So I'm literally copying and pasting Twitter stuff, which is totally okay. Just be sure you're reading along with the tutorials to understand why. And I'll add some lorem to both of these. Refresh the page. So now we got something like that, right? And it looks pretty nice. You know, we might at some point you want to customize it. At some point you want to bring in a graphics designer to help you customize it. But for us, getting to the point where we can start building an application that has data in it, and we just want to be able to pull out that data on a page, boom, right? Now, consider what this looks like. If I added a nav bar, it would blow your mind. And consider what GitHub looks like. Let's go to their main page. I'm not sure if GitHub uses Twitter Bootstrap. If not, they're using something really dang close to it, right? So this is not a toy. Like probably tens of thousands to hundreds of thousands of web developers are using Twitter Bootstrap all over the world. Twitter Bootstrap is what people are using. There are other systems because it helps us make pretty things very quickly, and lets us get on to what we call the domain-specific portions of our application. So, cool. Do we got that? So we got a container, we can add rows, we can have as many rows as we want. Inside those rows, we need to add columns for content to appear, so like cells in a table. Column lengths must add up to 12. That's the only rule. Inside of columns, we can nest additional rows. Make sure that you things, say, the nested rows, and then we need to have columns in those. And columns have to add up to length 12. Always, even for the nested ones. That's the gist of Twitter Bootstrap grids. Let's go ahead and make this a 3-column layout. So I'm gonna shrink this one a little bit, maybe make it 2, and then keep my main content and add another sidebar over here that will be 2 plus 8 plus 2. Is that right? No, 2 plus 6 plus 4. Right? Okay. So I've got my column D4 here. I'm gonna shrink it quite a bit. I'm gonna keep my 8. I'm gonna make my 8 a 6. And then I'm going to add another column here after that one. See, this is why I need to comment these things. Follow the line down. With this line, right there. I think. Yep, because the other one's my panel. So let's add another column there. I'm using 2 plus 6 is 8 plus 4. So call MD4. Close the div. Give it a header. And say right sidebar. And this would be an example of a 3-sidebar layout. Right? So you can imagine putting a whole bunch of content over there. I'll give it some lorem ipsum just so that we can see. Boom, right? Twitter Bootstrap's grid system. Caveat. So what you want to worry about when you're dealing with grids. At some may want additional spacing between these elements. Yeah, so you might go, you know, I wish there were more spacing in here. So I'm going to add some padding to that column. Or I wish my rows had a little bit more spacing, so I'm going to add some padding to those rows. Do not do that. So Twitter has like given these paddings and the spacings in their columns and rows precision to like 10 decimal points. If you look at their CSS files, if you mess with those numbers, the layout gets completely. So you cannot add padding to the columns or the rows themselves. And what I'm talking about is like I've got this call div here, and you say, oh, I want to add some extra padding, so I create my own class and say extra padding or whatever. Don't do it on this div for the column. Create another div inside of it, just immediately inside of it, whose only purpose is to add that additional padding. Use that div for it. Take that div as a structural element to organize the code inside the column, and then target that thing for the additional padding, right? Otherwise, you'll completely mess out the layout of the page. Twitter has very perfectly set those layouts. So that's really the only caveat that I can think of. And then again, we see a very nice effect as we resize the window. Eventually, this will stack. Boom. So now we see our navigational stuff on the left sidebar first, our main content, and then our right sidebar, so that it renders correctly on a mobile device. And I believe, if I understand the other options that Bootstrap provides, like we're using call MD4, you can see that Bootstrap has these other, like call XS4 and call, I don't even remember what the other ones are, call LG4 and stuff. They change the widths of these, the default widths of these things. And I think XS, like it says it'll be horizontal at all times, I think it prevents those things from collapsing. I'm not exactly sure.
Those are media queries. So like XS is for like a mobile device because that's small.
Okay.
And MD is for like regular desktop screen, and then large is for like.
But it still works on the mobile device, right? I mean, because when I still collapse this thing, even though I'm using MD, it's still collapsing.
Yeah. So it starts from the highest one and then like I guess cascades down. So like you can only set I guess styles for like a mobile phone, but it'll still work as it scales up.
Okay.
Just use whatever's like a little bit.
Okay. So what if I set all of these to XS? What would happen?
It would, I guess, it would work fine on a mobile phone. It would be like this on a mobile phone.
Okay. Yeah.
And as you went higher, it would just keep staying like that.
It'll just keep staying like that. That's what I was thinking.
MD is what you want to use, so then when you get to mobile size, it'll scale down.
Right.
And MD will be like what everybody's using on a desktop.
Yeah.
Then it'll look good on a HD screen.
So on a bigger screen as well. So I guess, so that being said, like if you didn't want it to stack on a mobile device, so you wanted to keep that normal layout, then you'd use XS instead, right? Yeah. That's the gist of that. Cool. So again, this is totally worth mentioning because we will make all of our pages look like this. It's a great way to lay out content. So, any questions about Twitter's grid system?
Is that file available that you were just working on, the grid.html?
I can make it available. Yeah, you want me to push it out there?
Yeah, that'd be great.
Sure. Make a note of that. I will add it the page for Twitter Bootstrap's lesson material, which is a few repositories back. So, but it'll show up at the top once I push it again. So, make grid. Actually, what I'll do is I'll make this whole thing available because we have the index and the forms. So, in case anybody wasn't following along or didn't get it all written down, I'll just make all this code available that we've gone over for the Twitter Bootstrap stuff.
In the Bootstrap class repository?
Yeah. So, make grid and other. Any other questions? Cool. There was still some content in Bootstrap that we did not go over. It was the component stuff. What I would encourage you to do is, if you haven't already looked at that lesson material, just look at it and go through the Twitter Bootstrap documentation, because literally all I'm doing is copying and pasting their tags. Yeah.
Yeah, good question about what part of it is the documentation, and the whole site basically is the documentation.
That's right. That's right. That's right. So all of the Twitter Bootstrap page, like this whole page. It's one big huge tutorial, right? So and they interweave the documentation with examples. So they're like, here's an example, here's why it works the way it works, sort of thing. Yeah. So and it is, as I've said before, and I'll just say it again, it's totally okay to just copy and paste this stuff. That is how Twitter Bootstrap set it up. So cool. All right. Let's wrap up what we were talking about last week on Monday. So we got through the JavaScript stuff. Everybody getting variables and data and types and values and stuff okay? Yeah. Please tell me you guys are all doing Code Academy. Definitely part of it. So, all right. So let's wrap up what we didn't quite get to. So it's the control flow part. So here's where things start to get a little more interesting. I'm going to go ahead and close the Twitter Bootstrap stuff. So let me close the web page. GitHub here, Bootstrap. Let me go ahead and close this guy. So I'm going to kill this in Sublime. And then in the console, I want to Control-C out of this too. So, and find yourself another directory somewhere. We'll be creating a couple of JavaScript files. So it can be anywhere you want. I have a lesson 6 here, so I'm going to cd into. Actually, it was part of lesson 5. Make dir JavaScripts, whatever, and cd into that. Into JavaScripts. Yeah, so I just made an empty directory for myself somewhere. Previously, we had been typing stuff into Node. So if we start up Node by itself on the command line, we get the Node REPL, the read eval print loop, where we can type stuff into it and it'll evaluate for us, like 12 plus 24 and all that good stuff. At this point, our programs have been really simple. We've got a couple of basic expressions, but not really much else, right? And our program structure, importantly, has been entirely linear. Basically, Node reads what we give it from the very beginning, executes it, and then waits for us to give it something else. And in general, or by default, that is how a program actually will work. So let's Control-C out of this. Sometimes you got to do it twice. Node will tell you. Create a new empty file called test.js if you hadn't already. We may have gotten that far, so I'm just touching test.js. And I want to open that up in Sublime, so find out, or whatever text editor you like to use, not Word or Notepad. So I'm just going to subble that thing. So I got this empty test.js file. And I can now I can start to add together this stuff that we've been typing into the REPL previously. So we remember how to do a variable declaration. We say var and then whatever the variable's name is, and then I can assign to it immediately. And this is a statement. This is a complete complete unit of code. So we end it in a semicolon. And then I'll say var age equals 32. I think we got this far. Again, a statement. So I'm setting up variables at the top of my program, and then I can console.log was a function that we learned about. And then in parenthesis, this is how we call a function. We're going to learn about this today. I go, my name is, with the spacing, and then I plus name, or console. And then underneath that, console.log, my age is, and the age. Save that. And again, this material is all up on the GitHub as well. So, if I move too quickly, that GitHub, the intro to JavaScript page has a program structure or control flow .md file. It's all in there, right? Word for word.
But you have to have 2 quotes,
Around where?
My name is, and then 2 quotes, plus the 2 quotes for space. Otherwise, it's going to bridge together.
Oh, so I've added the space inside of those quotes. Yeah, but you could do it that way too. So you're talking about, so I could delete that and then go plus space. Yeah, that's another option. So.
Short way it's faster.
But your may will be correct in some other senses, because normally spacing won't be built into like a variable value. So, okay, so once we've got that written, we can run it. So rather than typing node by itself and pressing return, we can point it out that we can point it at that file, node test.js, and it runs from top to bottom. Yeah, that's sort of the point of what we're talking about here. So those variables get declared, and then the console.log prints out stuff to the console, and boom. And then we remember now, this is how Node is starting up that Express application. When we type npm start, that's an alias for node ./bin/www, and that www is just a JavaScript file with some code in it. All right. Now, normally statements are going to be executed linearly like this. So we start at the top and we move down. This is good. This is what we've seen so far. But the control flow of our program. So we can set it up so that statements don't execute linearly anymore. We can skip statements, we can loop over statements, and we can jump between blocks of code using functions, which we're going to learn about just after this. Before we do that, actually, this is the first thing that we're going to learn, so let's do that. Let's blow out this stuff here and add some new data in, because the examples are based off of this. So I'm just going to say var alarm equals 7:30, so you can imagine I'm setting an alarm for 7:30. Var snooze equals 9, a 9-minute snooze. Var wake up, we'll just leave that one alone. Let's add another variable, var time equals 700. So we're doing like military time, right? So I'm declaring 3 variables here. At this point, I could run my program. So, yeah.
Well, I'm getting undefined when I'm trying to, and it looks like I'm typing just the same as you.
You might have a spelling error or capitalization error. It should the console should tell you what your error is. So if you look at it, it'll tell you what line number it's happening on. So let's see what that looks like. So eventually we'll learn a little bit about debugging. But let's say I wanted to use one of these variables in an expression, and I accidentally wrote time with a capital letter, so time plus 1. If I run this program, I get an error. Reference error, time is not defined. So remember, our variable names are case sensitive, and so what it's saying is, hey, I don't know what time is. You haven't declared that anywhere, yeah? And when we look at this, it's like showing us what's called the stack trace of where things are blowing up, where things are going wrong in our program. And one of these will actually be our file here. So it's the first one at object anonymous. There's our document, test.js:6. That means line 6. Yeah, this is where the bug in our program is. So sometimes Node will do a very good job of telling us exactly where things are going wrong. Other times not. But I can look at my code, and I can go down and look at line 6 and say, okay, well, what am I? I've got time misspelled. I'm using capitalization, so that can't be right. So I need to use time. Right? So first kind of control flow we want to is an if statement. An if statement checks a condition to see if it's true, and if it is, executes the following block of code. If the condition is not true, it will skip it. And so this is our first example of nonlinear execution. We can skip code based on a condition being met or not. And what this looks like is an if statement. So if, notice Sublime makes it into a purple there because it's keyword, in parenthesis, necessarily, the condition I want to check. So if time is greater than or equal to alarm. And we've already seen that this is just a comparison expression, right? That's why we started with that. So a condition will always be based on some kind of comparison expression. We're going to compare a couple of things. Or use Boolean values, like Boolean operations. So if time is greater than or equal to alarm, say console.log, the alarm is going off. Oh, I'm sorry, I put it in these curly braces here. This is designating the block of code that is associated with this if statement. So in a sense, this is the block of code that this if statement now controls. Save that and run the program. Nothing prints out. Why not? Because time is less than alarm. Yeah, right? So change the value of time to 800. Save that and run the program. And now the alarm is going off. Right? Conditional execution. We are now changing the flow of control in our program. Node is literally like encountering this line, seeing that this condition fails when time is 700 anyway, skipping over it and going to whatever comes next. Yeah, we're skipping over lines of code or a block of code in the curly braces. The syntax for this, and so we always want to know what the syntax is a general if and then some kind of conditional expression. This is the grammar for the language, and then statements, right? And statements include the semicolon. So it's basically this, and we can have as many statements as we want in there. To illustrate that, that's important. Let's illustrate that. So set my time back to 8 o'clock here. I could say console.log, the alarm is going off. I could declare another variable, so I'll say var next alarm equals time plus snooze. So I'm declaring a new variable, next alarm, and I might capitalize alarm there, because that's sort of the practice. And then assigning the result of an expression to it, and we know that time is 800 and snooze is 9. And then I could do another console.log.
So you can define the variable in the conditional?
Yes, you can. And Node has some very weird rules regarding that. I'm sorry, not Node, but JavaScript, which is really unfortunate. But for now, let's just be okay with saying, yep, we can define that variable anywhere we want. And so now I'm just going to say the snooze will go off at plus and then next alarm. And the important point here is that our block can contain as many lines of code as we want it to. Yeah. And since we've surrounded it by these curly braces, we've made this a block of code associated with the if statement. All of this will only be executed if this condition is met. We know it is, so let's save it, run the code. I get an unexpected token error. Good, I got a bug. What's it going on at? Maybe this one is test.js line 12. Oh, I left those guys in there, which don't mean anything to a program, to JavaScript anyway. There we go, right? So again, it's like we're learning how to build up programs out of expressions that are combined into statements, adding them all together. Yeah, so our program is going to be tons and tons and tons of these statements, one after the other. What if, let's go ahead and delete these last two lines here and just keep the one. What if we want to have the code say something else if the alarm is not going off, so if time is less than alarm? So you might think your first inclination might be to say, well, let's add a line down at the bottom here. So console.log, you can say the alarm has not gone off yet. Like that. What's the trouble with this? We need an else, so we're going to learn that, right? But the basic problem here is that this code will be checked. The condition might be true. If that's so, this code will be executed. But even if it is true, then the control just keeps on, like, falls down to the next line, and that guy gets executed as well. But that's not what we want, right? So when I run that, I get the alarm is going off. The alarm has not gone off yet. Something's wrong in my program. We can fork control with an if-else statement. Yeah. So we say if something, do this. Otherwise, or else, do something else. Yeah. And so this becomes one unit of a statement. We have an if statement and we have an if-else statement. We follow the curly braces here with an else, Notice how Sublime colors it. And then give that curly braces as well. So now we're controlling a second block of code that is associated with the else clause. And I'll take that console.log and stick it in there. And we tab this stuff similarly to the way we tab HTML so that we can see the nested structure of our code. Do get in the habit of doing that. So now, and then this is what's great about code, because it's kind of pseudo-English, although it might trip you up sometimes. This reads like English. Yeah, so like just read this to yourself and it makes sense. If time is greater than or equal to alarm, print something to the console. Else, print something else to the console. That's really not too complex, right? Save it and run it, and you'll see now we only get the one, the alarm is going off. And if we change our time back to 700, we'll see that the alarm has not gone off yet, and that's the only thing that it prints, right? So now we're doing a little bit more complex control flow in our code. We are going to always execute one of these. One or the other is going to get executed, but only one will be executed. Yeah? And then the rest of our program would continue running as normal if we had additional code there. Does that make sense? The general syntax for this, and then we'll take a break here. If some conditional expression, open up curly braces and give it statements. Else, open up curly braces, give it. And people have different preferences for how they organize or how they lay out the lines of code. You'll see some people like put the curly braces on the next line and put the else on the next line, or like that. Or you'll see people do it like that, but the else will be on the next line. You'll see people do it like that, the way I've been doing it. Be consistent. Really be consistent, and follow the practices of whatever group of people you're working with, honestly. Yeah. It doesn't really matter. If one way or the other helps you read your code, that's what it's about. It's really about your code readability. How easy is it for you to understand what your program is doing just by looking at it? And I've gone back and forth, but I now sort of prefer this compact look. So, but really do it whichever way you like. Okay, let's take a break. We're at the hour point. We're doing great. We've got a couple more pages of control flow, and then we're going to learn about functions. So we're moving right along. Sweet. All right, take a break. 5 minutes.
What have you seen the most out of in terms of syntax, like out of the three that you said, in terms of?
Yeah, like which way to learn that?
I personally put the else on another line.
I don't know. So I use different ones for different parts of my program. So when I declare a function, so if I do a function, right, function, my function, then I typically put those on their own line. But I like that because it says, hey, there's a function here, like pay attention. Yeah, this is important. But everything else I do more compactly like this now. So everything like inside the function. But that's only my personal preference. So it's really hard to say what I've seen it every single other way. Yeah. And then you'll see people do it ways that don't, you're like, what?
Yeah.
And then people will break ways too. Like you'll get a line that's just too long for the screen, and rather than letting the screen automatically line break it or soft line break it, they'll stick a return in there somewhere and hard break it. And people break it in weird ways.
Yeah.
I've never seen any consistent. So I think these are great. So there's probably a JavaScript style guide. And it's so Airbnb has published its JavaScript style guide. Some other GitHub has published its own style guide, and so you can read these things
and see what they're doing.
And they recommend doing things a certain way. Yeah. So this one is that one's pretty tiny. Let's look at the Airbnb one. Some of these are huge.
Right.
Yeah. So this is like, look at this. This is, I mean, look at this scroll. It's like everything, right? So like comments, nest conditional expressions and equality, like, so like how are they doing it, right?
So they have the colon and the minus.
And they discuss every single thing that they do with examples of how not to do it.
Yeah.
And so what would happen is, like, this is not necessarily the right way to do it, but if you started working at Airbnb, they would say, go look at the style guide. This is how you're going to write code. So, because it helps if everybody's writing it the same way, right? And when you have a team of 100 people or whatever working on a massive project, consistency is good. So,
I need to get some water. Yeah.
So I got this one.
Yeah. Kind of excited to get into this. Thanks for that. For explaining that.
Oh yeah.
That's every single person I've either talked to or done stuff for said something different.
And people feel really strongly about it too.
I just had a TA who was the grading Nazi.
It's like
silly syntax things where everyone else had been saying do it differently. He was like, no, you have to do it this way.
That's stupid.
Yeah.
They are right about. Sorry.
Oh yeah, no problem.
When you only have one line of code following it, technically the curly braces is not necessary.
Yeah.
That is.
That's the C syntax.
That's C syntax. So if there's only one line, it's assumed that that's the block of code associated with that condition, and that's the only one that'll be executed. It's easy to make bugs when you do this, though.
Yeah.
Because if you then add another statement here, this statement is not associated with this condition anymore. And it'll freak out because it sees an else. But worse is, if you don't have an else, you now have a bug, because you think that this is associated with that condition, but really it's not. And so, security check, you've just introduced a huge bug in your program. So, so people are like, look, just always put the curly braces in there, because then you can see exactly what's going on. And I would say every time that is correct. Like, you should never leave those curly braces off. That will just prevent headaches in the future.
Yeah.
From experience. From experience, they're like, if you don't, just put the curly braces in there. Trust us on that one. Java requires it. Yeah. Yeah. C doesn't, and I think they were going off of C syntax when they did it. So. Yeah. I am more a Nazi about spacing. So, and I hate that. I don't know why it keeps on starting it up. I do my tab sizes at 2, so it's 2 spaces. Mostly because I think it's more readable, but also it takes up less horizontal space, so that I feel like I can get through it more quickly. But people feel really strongly about that one too. Like, no, it has to be a tab and it has to be 4 spaces, and do not do it any other way.
Yeah, I've seen people be like, it has to be 3 spaces.
Yeah, what, like
physical spaces.
Right, yeah, right. And so you can tell, and Sublime is nice. You can tell it. You can say, okay, hey,
that's nice.
How do you want to render it? But also, do you want it to be spaces, or do you actually want it to be that \T?
Yeah.
And so, like, I could switch it to indent with spaces and make it 2. Now, unfortunately, those spaces are already in there, but like now it's actually using spaces for it, right? If I did the other one first, it'd probably be okay. That one is also more that's personal as well, and just be consistent.
Yeah.
So, this thing is a mess.
Yeah, they're always very sticky. Don't get the chocolate; it's even messier.
Sounds so good, though. All right, let's get started again. Okay, so we've seen that we've got if statements, and we've seen that we have if-else statements. There will be times when you want to execute conditionally based on another condition. So you want to do an if something, and yeah, you want an else something as well, but you want it to be really else if something. So, like, is the alarm late, or is the alarm really late? Is the alarm late, or is it not late? Yeah? So how would I check for that? There is an if-else-if statement that lets you check for more than one condition in your if block, in your if code. And so the way this works is like this. I could say my first statement is if time is equal to alarm. Let's say this time the alarm is really going off, because that's what it's for. else if. So now I'm combining the else with an if, and I can give it another condition. And this time I could say else if time is greater than or equal to alarm plus 100. So what's going to happen there? Node's going to see this, and the first thing it's going to do is add alarm and 100. So it'll be 8:30. And then it'll ask if time is greater than or equal to 8:30. And then only if that's true is this next block of code executed. And so I could say console.log, you're really late. And so again, I'm forking my code, but now it's not a if something, do this. It's like otherwise under any conditions. Now I'm saying if something, do this. If that's not the case, check another condition. And if that, do something else. Yeah. So I can check more than one condition in a single statement, an if-else-if statement, right? I can. So then I could say else if time is greater than or equal to alarm plus 10, console.log, you're not that late yet. Right? Because it's going to go alarm is 7:30 plus 10 is 7:40. If time is greater than equal to 7:40 but not greater than equal to 100 than 8:30, then execute that bit of code. And so now I could run this. I'll say set time to 7:30. So I'm setting my variable up here. I'll make it on its own line. Run the code. Oop. There we go. The alarm is going off. Change it to 7:50. This one will say that you're not that late yet. You're really late. Multiple conditions in a single statement, as many as you want. Yeah. Caveat, the trick here. As soon as one of these conditions is registered as true, none of the other ones will be checked. Yeah. If-else block will only ever execute one of the blocks of code associated with it. So as soon as you hit that true condition, it's done. It won't even look at any of the other ones. And so think about it. If I take this guy and stick it up above this, okay. Got some syntax wrong. There we go. And I set my alarm to, or the time to 8:50. So this should be really late, right? I'm way after 7:30. I'm over an hour after 7:30 in military time. But when I run it, it's going to blow up, which is not correct. Wrong bracket. Thank you. You can totally call that out in the middle of class. You're not that late yet. That is a logical bug in my program. It is not a bug because something's wrong with the syntax of the code. It's a bug because I wrote things wrong. Yeah, well, the worst kind of bug. It's looking through these else-if statements. It goes, if time is equal to alarm, well, it's not, so I should check the next thing. Else if time is greater than or equal to alarm plus 10, well, yeah, that's true. Execute this code, I'm done. I don't look at any other else conditions. It's finished. Yeah.
I could think of a way to fix that.
Well, you just move it around, which is how it was previously.
Oh, I was thinking if time greater than or equal to alarm plus 10 and
You could add an S in there. We can have a Boolean condition in here. So I say if time is greater than or equal to alarm plus 10 and time is less than alarm plus 100, then say you're not that late. Yeah. And so now, when it checks for the 8:50, it'll go if the time is greater than or equal to alarm plus 10. Okay, there's an and, so I need to see if the other thing is true as well. Time is less than alarm plus 100. Well, that's not true. True and not true is false, right? This is those Boolean operations that are super key and we use all over the place in programming. So now this condition doesn't get executed, and it will fall down to the next one and go, well, else if time is greater than alarm plus 100, that's true, gets executed, right? So that is one way to fix that. And so you want to be aware of what your conditions are specifying, and always, always, always pay attention to the order that you're putting them in, and know that only one of them can be executed at a time. So you really are forking your code, and it can only go down one path. Yeah.
Out of curiosity, which of those two options would you consider better?
This one is a little more loquacious, but I like it because it's specific. So specificity is probably desirable when you're writing code. Yeah. Like you're really saying exactly what you want it to do. Whereas if you move this one later here, what you want it to do, but it might still be a little ambiguous. Yeah. Other programming languages have different idioms and different sort of practices about how they write their code to be. Some programming languages might prefer a simpler version. I can see how Ruby might say do it the other way because we like code to be as little code as possible. I don't know. I think this is better in this case, though. Okay, so if-else statements. We can have as many else-ifs as we want. Only one gets executed. Now, what if we want some bit of code to get executed no matter, rather if, yeah, but only if all of the other conditions fail. I know you know the answer. What can I add to this? I'm going to add an else, right? So I can say an else on here. Else, as a final check. And so it basically says, is this true? No. Is this true? Oh, no. Is this true? Nope. Okay, do that. Yeah. So now we're saying if, else. And again, we can have as many else ifs as we want in there. So I could say console.log. What has to be the case if all of these fail? Alarm hasn't gone off yet. Yeah. Because we know that we're either equal to the alarm or greater. Oh, no, not quite. We could be greater than the alarm, but less than 10 as well. Right. So be careful. Yeah. But the idea would be that the alarm hadn't gone off yet. I could get rid of that. Oop. And now it's true. Alarm hasn't gone off yet. Yeah. And I think this is one of the really neat things about programming. Yeah. If-else statements are fundamental to all of programming. What does programming teach you to do? It teaches you to think really carefully. Really, really carefully. Logically, and with a lot of attention to detail. That is required of any kind of programmatic thinking. I think that is why mathematics as well, and they're obviously very related. It's not so much that you need to be able to do stuff with calculus, it's that it teaches you to think in a different kind of way. And that is important for argumentation, for understanding evidence, for all kinds of things. Yeah. If you want to be good at reasoning, this will train you. Cool. So that's not too crazy, right? Again, this pretty much reads like English. It's kind of pseudo-English. We can nest these things. So remember, this what goes inside of one of these blocks is just a statement or a series of statements. An if thing is a statement. So we could put additional if statements inside of our if statements. This is the nature of a programming language in that it's recursive. We can embed things inside of one another to build up a more complex program. So I just want to demonstrate that. I don't think it's too crazy a concept, but it gets complex very quickly once you start to do a lot of nesting. So if I say if time is equal to alarm, this is what we had before, console.log, alarm going off, and then I might have an else. Inside of this else, I could add more if statements that maybe are conditioned on something else. Who knows? So I could say next var next alarm, I'm just making this up, is equal to time plus snooze if next alarm is greater than or equal to 12 o'clock. Console.log, you're screwed. Else, console.log, hope your car is working. Whatever. It's just I'm being silly. I didn't actually put this on the GitHub. It's probably a little more reasonable. But here we see what's going on with a programming language. We're building up a program by taking statements and making them part of bigger statements. Yeah, statements out of statements with more statements. Yeah, and that's a programming language. And again, for the most part, it's being executed condition on things and fork, so we get to skip around. Yeah? And that is normal. You're going to see that all over the place. Okay, clear? I'm going to introduce you to one more control structure and then point you to eloquent JavaScript, because there are many other control structures that we have not covered, like for loops, do loops, things like that. I'm not going to go over those in class yet. Maybe we'll get to them. but they're in eloquent JavaScript, and if you get this, I assure you, you'll get that as well. So, but I want to introduce you to the veritable while loop that nobody really uses anymore. But it's a good way to demonstrate that code can loop back over itself.
What are they using instead of while then?
You see for loops a lot. Yeah, mostly it's you see for loop. Well, I don't see a lot of while loops. I have a very hard time finding a good reason to use a while loop. So let's talk about what a while loop does. Let's set alarm to 7:30 and my time to 7:20, and I can get rid of snooze. I'm not using it anymore.
Okay. JavaScript doesn't have multi-threading, that's it?
No.
Okay, so I couldn't see why you would use that.
While time is less than alarm. So a while loop, like an if loop, will have this conditional check, yeah? It's going to go while time is less than alarm. So time is 7:20, that's certainly less than alarm. Console.log, it's not yet time to wake up yet. Space plus the time, so I can see what time it is. Now, what happens if I run this program? I'm going to have an infinite loop. So what a while statement does is it checks its condition immediately while time is less than alarm. If its condition is true, it begins executing its block of code. It will execute all the code in there, like in the other series of statements, and then when it reaches that closing curly braces, the program will jump back up to the condition, check it again, and then execute that block of code. And it will keep on doing that. So it's that is why it's called a loop, right? It's literally going to loop through this, but every time through the loop, it's going to check that condition. Right now, that condition is true forever. So if I run the program, you can't see it, but this thing is basically shooting down my screen. Yeah. So I just totally wrecked my console. You can Control-C out of that. Control-C is the escape sequence to prevent that from happening. So what we need to do usually, every time you make a while loop, somewhere inside your while loop, you're going to change things so that eventually this condition becomes false. What I want to do is add 1 to the time. So time equals time plus 1. If you have some experience from other programming languages, you may know that you can also write that as time plus equals 1, or so this is a shortcut assignment operation that does exactly what we did earlier. Time equals time plus 1, or you can do time plus plus, which increments the value by 1, or plus plus time. There's 2 ways to do that. Those have different operational precedents, so maybe not use those. We're just going to be explicit and say time equals time plus 1 because there's nothing really that wrong with that. Now let's run it this time. Save it and run it. And now you can see how this while loop is working, right? Checks the condition. Condition is true. True. So it prints out our console message, increments the time by 1, checks the condition again, still true, implements the console message, and so on, and loops through the whole thing until it hits 7:30, and then it's finished. If I wanted it to finally print out time just to a less than or equals, now it goes through there, right? So this is these are just really great examples, in addition to being how people actually write programs, of how control flow changes in code. Yeah, our code is skipping around. Statements make code skip. That's super important, and it's really fascinating how this works on the processor. Cool. Okay. Questions about this? Not too hard, right? Again, look at eloquent JavaScript, because there are other loops that we'll learn about later. But go and make sure you're getting familiar with them now. Okay, now for the big guns. This is our second day of JavaScript. We need more JavaScript. Time to talk about functions. So this is up on GitHub. So again, check out our GitHub, github.com, OK Coders, JavaScript functions right down here. There's only one file. It's a big one. It turned out to be 15 pages, which means there's no way we're going to get all the way through it. Functions are an important topic in every programming language. A couple of references here worth mentioning. Eloquent JavaScript. Please be reading it, right? That's must-read homework. The JavaScript guide on Mozilla is pretty good, and then again, if you're not doing the Code Academy, that's your homework. Start doing the Code Academy. All right. The most important way to change the control flow of a program is with functions. Functions are reusable blocks of code. So you are literally setting aside a block of code and giving it a name. And then you can use that block of code from other places in your program by referencing its name. Yeah. And in some ways, functions will work like math. So they take an input and they can transform that input and give you an output. So they can take values and they can return a value. But they don't always have to do that. Sometimes you're just going to have a function because you like the fact that it organizes a block of code that you want to reuse over and over and over. Yeah.
How's a function different than a container
What's a container?
that we've been doing in the HTML?
Oh, okay. So right. In a sense, they have similarities, right? You're organizing blocks of stuff, but in HTML, you're not really programming. Like you can't call a container do this for me. So yes, they're both ways of organizing code. But when we start writing with programs, div really better than container. Once we start writing with code, we're going to see that we can like actually make it do stuff. Yeah, which we haven't been able to do with HTML so far by itself anyway. Okay, so I'm going to switch back into the Node REPL for this so that we can see some things happening dynamically. And that just means I'm typing Node by itself and pressing return. So I'm dropped into the read a value print loop. Declaring a function, so often called defining a function, as I say, sets aside a block of code and gives that block a name. So there's syntax for doing this. We begin with the word function. Function is a keyword in JavaScript, so it has meaning. It's That bar just got me. Sorry. So function is a keyword. As soon as JavaScript sees function as the first word on a line, it knows that the next thing you're going to do is name a function. So let's give our function a name. We're going to call it foo in the tradition of computer science, which comes from foobar, which is actually a bad word as far as I understand. Maybe not spelled with foo. So I am naming a function, and then we must use parentheses. And we'll learn that parentheses are for arguments, which let us pass parameters to our function, or for parameters, which let us pass arguments, excuse me. Now, just like we've been doing with our if statements and our while loops, we want to give it a block of code, so that means curly braces. So open up curly braces and press return. So what just happened here? Previously, when we were working in the Node REPL, we were only ever giving a single line to Node, and Node knew exactly what to do with it. This time, Node says, hey, whatever you're doing, you're not finished. You need to finish this. So the ellipsis is Node letting us know that there's more input before I know what to do. We could do close curly braces, and that would close our function, and we'd be done. But let's make our function do something. We're just going to have our function do console.log called my function. Make sure you're getting all your parentheses and quotes and stuff closed, otherwise Node's going to keep giving you ellipses. And then I can press return and close the curly braces. And if that syntax is correct, it will drop me back to the prompt. If we weren't typing this into Node, so if we were typing this into a text file, it would look like this. Function foo, open curly braces, console.log, called my function. So basically, that's what we've just typed into Node, right? Only we did it one line at a time. So first thing to notice here, one, curly or parenthesis, critical, yeah? So we're saying this is a function, here's the function's name, here is its arguments list, or its parameters list. I'm going to keep getting those confused. It's empty. This function doesn't take any parameters. We'll learn about what that means in a second. It does have a block of code. Here's the code associated with this function, console.log, called my function. Notice what did not happen. Called my function did not get print to the screen, right? This code did not get executed. Defining a function does not execute its code. It only sets aside that block of code and gives it the name foo. But it does not execute it. Code is not executed when it is defined or declared. Console.log works in the REPL. We can confirm that by saying console.log, are you there, or whatever. And console.log, in fact, prints are you there, and then we get undefined. Why do we get undefined at the end again? Close. This doesn't result in anything. Yeah, this evaluates to nothing, undefined. It has an effect. These are called side effects. It prints something, but it doesn't result in anything. Yeah, it doesn't have a value. Its value is undefined. Same thing with a function. When we declare a function, the result of evaluating that declaration, so node evaluates that to figure out what it's supposed to do with it, the result of that is undefined. Yeah? And unlike, say, 12, which is 12, or 12 plus 12, which is 24, right? We have declared variables as well. So we know that we can declare variables. Declaring a function is a lot like declaring a variable. So I could say variable var, so var, I'll call my variable bar, so var, which is probably awful. I'm not going to assign a value to it. But now I have bar, yeah? So I could type bar, and my program knows what's going on. And my program says it tries to evaluate bar, but a bar hasn't been defined yet. But I could assign a value to it. I could say bar equals 42. And now when I type bar, whoop, node evaluates it to its value. That's what it does with variables, right? What if I just type the name of my function? So what if I just type foo? So that's kind of interesting. Node is telling me that foo is a function whose name is foo. Maybe not all that useful, but this is a little amazing actually. So foo evaluates to itself, just like the number 12 evaluates to itself. What does that mean? What?
You can call it whatever you want, and it will,
It means something more than that.
you can pass
It's
it.
a variable?
It's a variable in a sense. It's not quite. It's not that it's a variable. What does a variable have? What does a variable hold? A value, data. Functions are values in JavaScript. That probably doesn't quite mean anything to you yet. That will blow your mind in like 2 weeks, maybe even next week. Yeah? Functions are not values in every language. They are typically values in functional programming languages, which JavaScript takes some of its heritage from. What this means is that we can pass functions around as bits of data. We can stick them in variables. We can do things with them besides calling them. We can always call them. You can always call functions in any programming language. But we can do more with them in JavaScript, which is slightly crazy. So if this is a bit of data, what is something that we already know that we can do with data?
You could store that in a variable.
I could store it in a variable. So I could say var foo reference equals foo. So now type foo reference. Foo reference is a variable whose value is the function foo. Yeah? So it's now holding on to or pointing to that bit of data. This is awesome. And it is one of the reasons why people like to use JavaScript. We're gonna see why when we get into the asynchronous programming stuff, which Node is built out of. So it means that we can like take functions, stick them in variables, and use them later on whenever we want, which is pretty cool. It also means that we can return them from functions, as we'll learn about. But that's pretty advanced stuff. Cool. But I want you to be aware of this right now. This is a hint of things to come. Normally, what we really do with functions, as the gentleman was saying, is call them. So we've got this console.log stuck inside of foo, or whatever else that function is doing. How do we get it to do that thing? Well, we need to call the function. Functions are a little bit different than variables in the sense that I can't just type its name. To call a function, I type its name with parentheses. And now the block of code associated with that function is executed, and then the function evaluates and returns whatever its result is. In our case, the result is undefined. We'll see that we can actually have our functions evaluate to a result in a moment. But this is the basic stuff, right? We want to be able to call our function. And we call our function with the name and parenthesis, and that's it. Yeah. So there's some syntax here. The syntax for defining a function is always function name, parenthesis, curly braces, statements inside. And the syntax for calling a function is always function name with parentheses, right? So this is the general syntax. But this is a reflection of what this document pulls up, which is the JavaScript grammar. So when I talk about building statements out of expressions and building more statements out of statements, that's this. So that's pretty cool stuff, but a little beyond the scope. It's more the theoretical. Cool. Let's see an example of how this works. Go ahead and quit Node, so Control-C out of that. We're going to make a slightly more complex bit of file here. So we can see how functions affect the flow of control in a program. So find Sublime and make that function foo up here. And let's do console.log. Dang it. So foo has been defined but not called. Call foo, and then console.log after foo has been called. And I might separate these out or break them up into slightly more reasonable bits of lines here so you can see what's going on. Can everybody see that okay?
Question?
Yeah.
I know it's getting ahead, but can functions have a return type?
Oh, yes. We cannot specify their type. We never specify types at all in JavaScript, but they can have a, we can return a value.
Okay, thank
Yeah, we'll definitely get to that.
Cool. I mentioned how weird that is.
What's that? That they don't have types?
That, yeah.
If you come from a Java world or a strongly typed language, it's definitely weird.
It's C++, Java, and C#, so.
Yep. So the other side of that is Ruby, Python, and JavaScript. So
They don't have
they're loosely typed languages, or better said, sort of dynamically typed. So that was in that test.js file, which we should still have in our working directory here, right? So let's run it. And we get foo has been defined but not called. Called my function after foo has been called. So how is this program getting executed? We're starting up with our function definition. So again, it's linear. So we start at the top. Node sees this and go, okay, you defined a function. It doesn't call the code, remember, but it defines it and sets it aside to be used as its name. And then it hits console.log, so it says that. Then foo is called. So our program's control flow jumps to the first line of code in our function. The function gets executed. When it sees that the function is finished, it jumps back to where it was and goes to the next line of code. Yeah, that is pretty radical control flow change in a program. And it gets crazier than that. And again, it's pretty magical how a computer processor handles that. If you've ever heard the word stack, that's what's going on. It's pretty neat. It has all kinds of crazy memory management stuff that happens in the background, but I just think it's cool. So, what would happen, if you've already read ahead, don't answer this, if I take my function definition and put it at the bottom of my file instead, and I try to execute my code? What's going to happen here?
Won't show it because it goes in order.
Goes in order, yeah. I haven't defined it yet, right? So, as we've seen with variables, like what if I tried to reference the variable hello? So I said console.log, and the variable is hello. And then below that, I say var hello equals something. So that should blow up, right? Hold on. No, you'll.
What kind of error would that be?
What kind of error would it be? Well, let's find out. Let's run the program. It's no kind of error. Why?
Because it's not syntactically wrong.
Why is it not syntactically wrong? So what has to be happening? What has to be happening in order for foo to be available to be called, even though it's defined down here?
It has to have memory.
Has to have memory?
Values.
In a sense, it's got a kind of memory.
Priority.
Priority. What does that mean?
It means that function output is evaluated first before anything else is.
Yes, specifically. Not that it's evaluated, but that it's defined, right? So how would that happen? How could this be defined before this code gets called?
Wouldn't it be with the compiler and how the program translates that text into machine language and puts it out on the screen?
In a way. So we say that that node, so it's not a compiler, it's an interpreter for a language like JavaScript, but they're similar, takes 2 passes through our code. On the first pass, yeah, looks like you were about to have a revelation.
So it's like parsing it and finding function.
In a sense, that's right. So our program is being parsed twice. On the first pass, it only looks for function definitions. That's all it's doing. It doesn't do anything else. It finds anywhere where a function is defined, takes that block of code, and sets it aside. And then the program actually begins executing from the top again. Yeah. So that means we can define our functions anywhere we want. That is not the case in every programming language. So like C, so you have to have, maybe not Java, but in C definitely. So you have headers, and you have to like define your function arguments in the header, and then you could define your function later on. JavaScript does not care. JavaScript takes 2 passes. Yes?
If it's an expression, it will not hoist.
Oh, good. Oh, hoisting. So great. So the technical term for that is hoisting, which I'd forgotten. And that's right. So what if I did, so we saw that we can assign a function to a variable, right? We can assign a function to a variable when we declare it. So I could actually say var foo equals function. Now that's going to look a little mysterious at this point, but we'll get to it later. And so again, I'm defining my function here, but I'm assigning it to the variable foo. And this is different. Yeah, this is not the same thing as like declaring a function. This is declaring a variable and assigning it a function value. And so now if I do this, as Maiwa was saying, I get an error. But look where I get the error. I don't get the error immediately. My code works until it, and only then does it break. Yeah, that's because this is not a compiled program, so we don't catch errors like this until we try to run our code. But that's a great point. So we're going to learn more about what are called anonymous functions and assigning them to variables very soon in a future lesson, because that's one of those powerful features of JavaScript that people really like, and Express uses it all over the place. So cool. So let's stick this back up at the top of the file. I think it's wise to put all our functions up at the top of the file because they'll usually be important sort of ways to organize our code, and we like to see that. We can define as many functions as we want. So I got function foo. Let's define function bar. And I'll say console.log calling bar. It's not very exciting, but that's what it does. So I can have lots of functions. I could have more functions. I can have as many functions as I want. Yeah. And they all just set aside blocks of code. None of them get evaluated. They all just get defined. And recall, I said that I could call. Call functions from anywhere. Yeah. So here I'm calling foo from like the main sort of top level part of my program, but I could call a function from inside a function. Nothing wrong with that. So let's call bar from inside foo. So now it's got like the part of what foo does is call bar. When I call foo, so the way my code program gets executed, first pass, define all the functions. Second pass, skips all this stuff, goes to foo. Control flow gets sent to here. Console.log is executed. Bar is hit, the call to bar. Control flow jumps to bar. Console.log is executed. We end at bar. Control jumps back up to the end of foo, and then control drops back down to after foo, right? So now we're doing some pretty more complex manipulations with the control flow in our code. But none of this is that crazy. Yeah, I mean, if you're just reading what's happening, it's not that bad. When you're writing the program that interprets this thing and then actually handles all of the routing for your programming, that gets pretty crazy. So if you get really interested in this stuff at some point, you might be interested in writing compilers or studying compilers or interpreters. Then it's nuts. So let's run this. And we see called my function and calling bar, just as we would expect, right? But the key lesson there is that we can define as many functions as we want, and we can call them from anywhere we want. Let's confirm that one more time with an if statement. So I'm going to say var age equals 21. If age is, actually say age is equal to 15. If age is less than 21, call foo. Otherwise, call bar. And so what's the lesson here? Calling a function is a statement. We can put statements inside of if statements. So we can call functions from if statements. Shouldn't be a surprise. Yeah. So I just want to emphasize the fact that we can do this. We could do the opposite. We could have if statements in our functions. Right? We can start to nest this stuff as deeply as we want. That's the thing that we really want to be sure we're getting our heads wrapped around. We build code out of code. Yeah. So it's like having Lego blocks, except for you combine them together, and then that becomes one Lego block, and you can use it for something else. So, is that clear? Any questions? Yeah. I don't know. I don't know how code blocks got their name. There's probably a really good historical reason for it, and it's probably from like the 50s. Were Legos around in the 50s? Maybe. I don't know. Okay. So we were asking about can we return a value from a function? Yes, we can. So let's start up the node REPL again. So I just typed up node. So now I'm in the interactive mode. This is why I'm going back and forth, yeah? So sometimes I want to be able to interact with my code as I go. Other times I just want to run a program. So normally we see this, function, no value. So I'm declaring a function, calling it no value. Make sure you have the parentheses. And then I'm just opening and closing curly braces, and it's undefined, which is always the result of defining a function. And I call no value. And the result of no value, the result rather of calling no value, is undefined. That's okay. This is the default consequence of a function in JavaScript. So different programming languages work differently, and some programming return something. In JavaScript, calling a function results in something. Just like evaluating a variable results in the value that that variable has. Same thing in JavaScript, except for by default, it's undefined. So very much, it's like saying var variable no value. Var variable no value, excuse me, is also undefined. Yeah, these are parallel. But the corollary, so if I assign a value to my variable, so variable no value equals 12, now it has that variable or value so that it will evaluate to that. It results in 12 in an expression. A function can result in a value as well, and we say that it's returning a value when it gets executed. And so let's define another function here called hasValue. And I want this value to be 42, so I say return 42 colon. So return is a keyword in JavaScript. It is a special instruction that says when you execute this function and the function is finished executing, the result of the function is 42. So the result of evaluating this function, in addition to anything else it does, is 42. And then close curly braces. So that now if I call hasValue, its result is no longer undefined. Its result is 42. Because I'm returning 42. That is what a return statement does. It causes the function to have a value when it is finished executing. We can have more than one return statement in a function. So a function can evaluate to different values or have different results depending on which return is called. Yeah. So let's declare a function called SumValue. And I'll say if true, so this will always execute because true is always true. Return, in quotes, true for sure. So I'm returning a string this time. Close my curly braces, and Node nicely tells me that I've got some indenting going on. So I close one of the curly braces, and then I say else, open up curly braces, return, in quotes, nope, false, or whatever. Close the curly braces, close the other curly braces. So there's a function that we just defined right there. I think admittedly, it's a little confusing doing that in the Node REPL since you can only do it one line at a time. What I've typed in, I'll do it in Sublime so we can see it clearly, is this. So that's what we just defined, one line at a time. And so look what we've got. We've got two return statements. Depending on what the function does, we can return a different value. The function can result in a different value depending on what it does. And so when I run this guy, I run SumValue. It's going to return true for sure. So that is what the function evaluates to. Again, in addition to anything else that it does. So it might print something to the console. It might make a network connection. It might go feed Fido. These are called side effects. They're the other things that a function does. But a function also returns some value, or it's undefined. But when it returns a value, then it evaluates to that. And again, this is just like having a variable stand in for some result. Yeah. Now we have a function that stands in for some result. We can do stuff with this. Yeah. So if I call some value, I'm going to get a string back. So I can use that now in expressions. So I could say console.log hello space plus call some value. And now I have this larger expression here, hello plus calling some value. We know that some value was going to get order of operations, function execution happens first here. The result is true for sure, so this gets replaced with the string true for sure. That is added to hello, and then the whole thing is printed out to the console, like that. Yeah. This is no different than what we were doing with variables before, right? Because when a variable has some value, some piece of data in it, we can use it in expressions. Same thing with functions. So like if a function returns true, so var returns, or sorry, function returns true, so function returns true. I'm going to do it on one line. Return true. There we go. I define my function. I could say if returns true. And that's the equivalent of saying if returns true equals true. That's short for saying this, right? And then do whatever. Point being, though, that we can now, again, use these function calls inside of expressions. So we're going to see that all over the place. That's a shortcut. So you might think, well, easier to assign it to a variable first, so you could say var result equals the result of call, and then check result. But that gets tedious. Oftentimes, if you see code like this, where you're just assigning the result of a function to some variable, and then you use that variable once, just go ahead and call the function. A return statement does one other thing that is extremely important. So a return statement does two things. One, as we've seen, it returns a value. It causes a function to result in something. Two, it prevents or stops execution of the function. Once a function hits a return statement inside of its block of code, it immediately returns back to the point in the program where the function was called from. And so let's see this in Sublime so I can sort of point this out. I won't necessarily execute it, but function stops early. I could say console.log up here, return console.log down here, and then call stops early. So notice I've got, the point here is I've got this return statement. Two things to notice about it. One, I'm not actually returning anything. Like I'm not returning a number or a 12. Returning nothing is the same as returning undefined. So that's what Node understands there. That's okay. You can always return nothing. So and it just results in undefined, which is what it was doing anyway. Two, the important thing is that this return statement comes before this guy. Yeah. So when I execute this code, so Control-C out of Node and run node test.js, it only prints out up here. So control flow, now first pass, define my function. Second pass, skip all that, call stop early. Control flow jumps up to console.log, executes that, or basically the top of the function, goes to the next line, which is return. So the other consequence of return is that the control flow is immediately returned back to where the function was called. So that return has two effects, and it names both. So it's a great word that has two meanings. One, it returns a value. Two, it returns back to where you were. Yeah, hold on. So anything that's after that return statement gets skipped. You will often see code that does that on purpose. This is okay. This is a normal thing to do. So I could have like var result equals big operation that does something important. Yeah, so I call some function big operation. Then I say if result equals error. Something really bad happened. Something so bad happened that I should not do everything else that this function does, because everything else that this function does depends on result not being an error. So I return early. I get the hell out of there. Go, don't execute the rest of that code. Probably I raise an exception, but we won't learn about that. So, yeah.
Question. What is the difference between return and break?
Break is used in loops. So we didn't go over break. I won't talk about it now, but a break is used to stop a loop from executing. I guess I could stop a while loop while you know, time is less than alarm. Do stuff. I could have a break in here. Oh. When any kind of loop, it doesn't matter what loop you're in, when a loop sees a break statement, it breaks out of the loop. That's what it does. And so it doesn't check the condition, it doesn't execute code, do not pass go, it jumps back to the end and just keeps on going with whatever code. So it has the effect of breaking out of the loop. So in a sense, it's similar to a function, right? It exits prematurely, but break is used specifically for loops, and return is always used for functions, right? So, but yeah, but similar in some ways for sure. Any other questions? We've already seen that you can use the result of a function, right? When a function returns something like a string or a number, then we can put that in expressions and use it for other stuff. We have only about 5 minutes left, but we've got quite a bit more to do with functions. We got about halfway through that, so that's pretty good. But we're going to stop now, because this is a good stopping point. The next thing that we're going to talk about is passing things into functions. To give you a hint of what that is about, without going into details, normally when you have a mathematical function, and they're called functions because they come from math, you have something like f of x, if you guys remember from algebra, equals 4x plus 3, right? And then I need to call f of x with some value for x. So I would say like f of 4 equals. And so what do I do here? I'm like passing 4 and saying, okay, I want 4 to be x, so that should be a 4 right here. So it should be 4 times 4 plus 3 is 16 plus 3 equals 19, right? And then I could call f with some other value, like 1. Only now it's 1, so it equals 4 times 1 plus 3 equals 7. Same thing that we're going to do with programming. This is why a function is called a function. We can set up our functions to take parameters, or they'll have parameters, and then we pass in some value for that parameter, and then anywhere in the function where we refer to that parameter, we treat it almost like it's a variable, it will take on whatever value we're passing into it, and the code will get evaluated with that information. Yeah. We're going to get into that next week, I suppose, but that is what is coming. And once we understand that, we can pretty much do whatever we want with functions.
Are those, are the arguments separated by commas or white space?
Commas, yeah. Yeah. We'll get into it, though. So I could write that. So this algebraic expression, f of x equals 4x plus 3. In JavaScript, that looks like function f with x as a parameter, return 4 times x 3. This is what we're going to learn about next week. So go ahead and read this stuff. So you may have already encountered this in Eloquent JavaScript. You might be encountering it on Code Academy. It is now on the repository. Read about it and do the homework that is assigned for it. And so I want you to actually go ahead and do the homework even though we didn't cover it in class. Let me show you what our homework is here real quick. So OK Coders, of course, on GitHub. I wonder if it shows up. Oh, there we are. Look at that. That's not bad. We've got a good SEO. We're the only OK Coders. Yeah, but our web page is first, which is perfect. Everything in here is, except for OK Codes. I don't know who they are. So JavaScript functions homework. There's a whole bunch of files here, .js files, that you want to execute in Node. So you need to download this entire repository, and then go into it and look at this code. So I click on boolean.js. There's a bunch of comments in the code. That's the homework assignment. And then there might be some code that you need to fill in. Going to be some code that you have to write and so on. So basically, it's practice doing everything that we've been doing with JavaScript so far. It's not a lot. Making this stuff up is really hard because I'm like, I have to make stuff up that doesn't quite work and get you guys to do it the right way. It's really annoying. And it's not as much the real world as like actually building an application, but it's important and it's good practice. And so I want you guys to please do it, and we'll go over that. We'll definitely go over it in class. And it'll be good because you're going to have to read the rest of the stuff on functions and actually do the functions assignment in here, which is functions.js, where you write functions that take parameters. So I want you to kind of get frustrated with this a little bit and force yourself to like work through it. Get used to like being frustrated sometimes when you program. How do you get this repository? So this has come up before. So you want to get all this code. You can download a zip file. That's one way to do it. So you can just, boom, download the zip. There it is. Show it in my Finder. Unzip it. And bing, there's everything. So now this directory lives somewhere on my computer. If I cd into that directory, I've got access to all those files, right? So I'll do that from the command line here just to show you. I can cd into, that's not the folder, it is, oh yes it is, this folder, boom, now that's where I am, and I have those files. So I could actually execute one of these files, as we'll do with like node boolean.js, so that's what you'll be doing in your homework assignment. It says that in the comments. Run it, and you'll get some stuff. And you just have to read the assignment to see what that stuff is about. Like one of them involves getting some tests to pass, so built-in.js. There's a bunch of code that you want all of these things to show up with test 2 passed, test 3 passed, and so on, right? So you just have to fill in the code. The other way to get this, go back to my home directory, cd, I'll just do it from there, is with Git itself. And so I know Milo mentioned this to a couple of you guys, and I've included instructions for this here. So one of the things Git can do is pull down repositories from other computers. So we'd use it so far for working locally, and we've seen that we can push to remote repositories, like we can push it to Roku. We can also pull it from a remote repository. So when it lives somewhere else first, the command for that is git clone. And the URL is provided over here, the clone URL, but I just embedded it right here. You can literally copy and paste this into your terminal somewhere. So I'm in my home directory. I'm going to paste that in there. And Git is going to copy all of those files from the repository up here and put it inside the directory with that name, JavaScript functions homework. So I can cd into that, and there's my homework. Right? That's probably the easier way to do it, because you need to be in the terminal anyway, because you're going to run all this stuff with Node. Yep, right. Really easy, right? Boom. Let's go to McNally's. All right. Thanks, guys.